bearing. It goes all the way out to the edge. That was kind of in the design when I did it originally. Well, when I put the down tail on that, how it's curved downward, that basically takes up 3 millimeters worth of height. The spacer takes up, the down tail does like 5.5, 6 millimeters, and the spacer does another 2.5 millimeters. Okay, so together it levels the whole thing out. But I needed, because of the way it's twisted or curved, bowed, I needed to move the clip more forward. And when I moved the clip, it actually stuck out too much. So I had to shave off part of the clip. The little nibs right here, because they stick up too far. So in the end, everything worked out nice. I was happy. I do like that little curvature on the bottom. It's an extra thing that I haven't done on any of my other robots to actually curve the plastic. Yeah. To bow it or stretch it or whatever you're gonna call it. Yeah. But it's neat.
You don't heat it to bend it, do you? You just,
no, you just when you put it on there, you just push it in place.
Yeah.
And
So what's because of these slits, right?
Yeah. That's what makes it easier to bend.
Yeah. Right.
Yeah. There's 2 slits in there extra that don't do anything.
Yeah.
And it's to help it bend a little bit easier.
Makes it look more like a tail.
Well, kind of like a lobster tail.
Like a lobster tail. That's what I was thinking.
Yeah. But I remember you saying something about the hammerhead.
Yeah.
Right. And I was like, okay. You see,
y'all named it after me.
I tapped these a little bit too much, so I used some fingernail polish to put them in. So this, on this version, there's a little bit in there about like some changes on how much this holds the motors in place. So this is like a full motor width. This is a half motor width. And some of that was because when I did the layout, I constrained myself to 400 by 200 millimeters, and I simply needed more space. These are notched because I needed the space. I needed to be able to slide one piece between the other pieces for layout. So I go back to the idea of design for manufacturability, just to see what all I can fit in there. And
I honestly thought that the top plate was going to be a little bit more curved.
There's no need for like these extra, the corners back here, right here, don't need to be that they could actually slide a bit more forward. When you put the card on there, the Uno and the other piece, it kind of fits out there. And having a little bit of space out here, I was thinking HC05 or the Wi-Fi module, it kind of fits over here rather than being up here. The whole reason for doing this is just for the LCD.
Yeah.
I kind of like the LCD being up there.
What's the little spring thingy?
That is just as much to say, what are these for? If you take a normal ink pen and you put
I see, it's a retractor.
Yeah, it actually, the servo takes the ink pen up and down.
Yeah. But
the clock spring allows you to not have absolute pressure. You have flexibility.
Right.
So when you put the pen down, it adds a little bit of force to it. That way, if it hits a bump or something, it doesn't damage the servo.
Right.
Cool. I mean, there's a lot of flexibility in positioning the pen and stuff. So, yeah. The other reason I wanted to make sure this was more flat was because the ultrasonic sensor, when it hits flat objects, if you've always got it back like this, you're definitely losing some accuracy.
Yeah.
I tried to make sure we had plenty enough space for the prototyping area. The main reason for this versus this, when you look at them, there's darn near all the same parts. It's an Uno, a breakout board. In here, though, let's see, on the outside, there's servo. There's still light sensors, ultrasonic switches. They're both going to be able to use the 6-pack AAA batteries. This one though has the motor control board down inside. This one, the motor control board is built on top of the Uno. It's all one shield. On that shield, it also has a single servo breakout. So this just plugs right into it.
Buzzer.
The buzzer's built onto it. The Bluetooth communications is all together real easy. The other stuff is together pretty easy. That breakout board simplifies a lot of the wiring, so you don't have this nest. I think that
are you making the breakout board, or is it
no? We're buying them.
Okay,
it's a purchase item. So the only part that we're actually manufacturing is
chassis.
the black chassis.
Yeah.
So when you look at this, a lot of the wires, you got to get down inside and well, what if you did this wrong? Even this is a little bit tough to get to.
Right.
Here, the motor wires are right here, ready, available to solder on after you've assembled it.
Mm-hmm.
You need to make sure you put these pieces on, at least the servo and the ultrasonic. Mount them in place before you put this plate on.
Mm-hmm.
But everything else is mountable later.
Mm-hmm.
You can solder things later. The battery goes in there later. The space in here has enough space for either the 6 AAA battery pack,
There's a lot of room.
or 2 18650s, or I imagine you could get a depends on how it's shaped. It's the 8-pack of double A's, the really long 8-pack. Get it in there. It just depends on how it's shaped.
Mm-hmm.
But the whole idea of this was really to make it simpler to assemble.
Yeah.
And wiring it outside once it's together. Because a lot of the students, when they were putting them together, they put together the frame, and then they were like, "Oh, now we got to put the wires on it. I got to take it apart again." That was really annoying for them.
Yeah.
So the goal of this robot was to make what we were calling a level 1 robot, an easy to assemble robot.
Yeah.
Can I do it? Can I do it?
Yeah. So as I was designing this, it got more and more complicated.
That's why
more and more pieces.
That's why you need me there.
Yeah.
Keep it simple, Ray. Keep it simple.
So I got it more and more complicated, added on all the little features and stuff. And then I was like, oh crap, it's not a level 1 robot anymore. A level 2. Okay? Because there's just more stuff there. I think what I need to do is to step back, go with like the D1 Mini has built-in communications, right?
It's an ESP8266.
Yeah.
Wi-Fi. Yeah.
And it can be programmed inside the Arduino IDE.
Yeah.
And I'm sure there's a motor board that it can be right onto it.
They have the Wemos guys have a motor board, although it has some issues.
It works really good.
After you reflash it.
After you reflash it. But it's super easy to reflash.
Yeah.
Okay, so
that's super easy.
If we flashed them before,
yes,
I would
suggest doing that. Although that adds to the
expense and cost and time.
Yeah.
It's more of a time-consuming thing, but if you set up a
fixture for doing it,
yeah,
it shouldn't be that hard.
Yeah.
It'd be a piece of cake to knock off a bunch of them at one time.
But doing 50 of them in a day?
Oh yeah.
If you set up like a jig or something, you probably can knock a couple hundred of them out in an hour.
Okay, well, awesome.
It only takes about, I don't know, 5 seconds to reflash a stupid thing.
Okay.
There's not that much code there.
You just go flash, 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 change, flash, change, flash.
Okay.
You'd have to, it probably would take longer to make a jig than it would to actually flash stupid things.
That would be worth it.
Yeah.
Right now, I've got the ESPO ones. They're really the easy little Wi-Fi.
Yeah.
Flashing those takes 30, 40 seconds.
Yeah.
And it's just something that has to be done. Anyway, I want to say thanks to Leroy for helping me get this started and banging out all the ideas back and forth and stuff. I think that there's enough differences between these two that it was worth doing. There's still a couple mods that need to be done to the design files, but I think this is ready to go. 9 more robots on the list.
Hey, can we start with small stuff? Let them flourish and go next.
You saw my ESP8260 or my Wemos D1 mini robot. I was using the mini shield.
Yep. I need to have something that's simple, easy, cheap. I mean, real low cost. I had
those boards are pretty cheap.
Yeah,
Just the added cost of reflashing them.
I had a customer contact me yesterday or day before yesterday, and I called him back today, and he has an order for, I think it's 2 or 3 maker spaces that he's building in schools, and he's wanting to buy robots, 10 robots each, at least 10 robots each. Those are starter kits. So each makerspace is going to have a class probably every 3 months to buy another 10 robots.
Well, that's cool.
10 robots, another 10 robots. But this guy wants to buy them wholesale.
Right.
And I'm like, well, let me think about that.
Yeah.
So he wants something of a curriculum, assembly instructions, schematics. I mean, I don't mind assembly instructions, schematics.
Because everybody needs those.
Everybody needs that. To do a curriculum, I don't know.
Yeah.
But one sheet that says this is why it satisfies the STEM program information, and then there's another standardization for science targets that it hits, and I need to be able to have that to say that while assembling this robot, you learned this, which satisfies programs within the school curriculum.
He needs that so he can appropriate the funds to pay you.
Yeah, so he's saying that the state says that this is an appropriate learning package. And if this is the right price compared to a VEX package, because you know how much VEX components cost. I mean, that's a lot, really. But if we could sell this to students at $50 for a kit,
you could sell all 10 of them for the cost of one VEX unit.
yes. Okay. We were looking at those boards, the motor 298P motor shield boards. Do you remember the price that we were finding them at?
8 and some change.
8 and some change? $3.
Where'd you find them for $3?
China.
Alibaba.
Duh.
Or AliExpress.
I couldn't find them
Well,
on AliExpress.
you have contacts over there.
It's
So.
Taobao.
Oh, yeah. Uh-huh. That's hard to use if you don't know Chinese.
That's true. That is very true. Okay.
I've tried.
And
You Google Translate to.
I don't speak Chinese. I just tell Becky that, hey, this is the picture. This is the English description. And she finds it and sends me a link. And I just say, yes or no, that picture's wrong. Next one, here's the link. And I look at it, the picture's wrong. And
I want one if you order.
I ordered 100.
Well, I'll give you $3 for one.
I bet.
Be very happy to do that.
There's a little bit of shipping in there too.
Yeah.
$4.
We got to put it in a crate. And
You're getting
with
stuff shipped
50
anyway.
laser machines. So they're not going to get here until early to mid-February, but they're on order.
Oh, you found them for the right price. Well, you said there's absolutely no reason why they should be $8.
Yeah.
We knew that when we saw them.
Yeah.
But I figured $3, I can handle that.
Yeah.
Okay. So I'm going to throw together a bill of materials for this to see what an actual cost would be. The battery compartment. I'm not going to. The switch is voluntary. I know we knocked that switch out.
Yeah, it fell out. So
I'm going to make this switch voluntary. Basically, what I'm going to do is it's going to have a power cord come out, plug it into the Uno, and it's just going to sit there. And what we'll do is, in order to make it change mode, you'll hold 1, click, goes to mode 2. Goes mode 1, click, mode 2.
I see.
3, mode 3. Okay, so that's what I think I should do for changing modes, or that way when it turns on, it's on. It'll beep. You can communicate with it, but in order to make it do something, you're going to have to hold it and do, the other one to do a certain number of clicks.
Yeah. Seems like a reasonable way to go.
Unless you reprogram
Right.
it.
Right.
Cool.
I like it.
Do you like the bent tail?
I do
Yeah.
like the bent tail.
I like it being flat. That's a good thing.
Oh, the way
The whole thing ended up being level. It's not that bad without it, but
right. It's not bad, not horrible, but that definitely is right. It's interesting to put it together on the bottom though,
yeah.
because that little screw head, you kind of gotta like warp it, snap it in place. It's cool. Something I did not mention.
Yeah.
All these slots are in here.
Mhm.
There's 5 total.
Mhm.
It's for whatever battery you choose to move it back and
Right.
forth to change your center of gravity.
Ah.
So you
Yes.
get to choose your own center of gravity. I do need to do a little bit of cable management, wire management. That's where I need like a hole slot over here, maybe a hole over here.
Yeah.
I
Of
need
course,
numbers.
you can run some of your wire. Well, you don't really need to. There is no real wire under there.
No, there's not.
So
I mean, your motors.
Is there anything inside that black part? Or is that just one?
That's where the battery goes.
that's
That's
just
it.
the battery.
That's all.
There's nothing else in there.
Nope, that's nothing there. That's the problem with this. There was too much stuff inside.
Yeah.
In there,
I like
just a battery.
The problem
I
with
like
that is
Simple.
not just too much stuff inside.
You
There's
couldn't get to it.
you can't get to it. That's
You can't even get to it with neither one of those
I
pliers.
don't even
you
wanna
have-
start. I can't even look at that.
you have a hard time putting it together just because it's small anyway. It's just,
Yeah.
Yeah. With this one, you're gonna have 2 wires and a connector, and it literally plugs in place. And the other one, 2 wires, the connector,
How
plugs on
many
the
wires
other
did
one.
we cut out?
3 total. That one, this one, and the one I tore apart.
We should cut out another one tomorrow, and then I should write the directions on how to put it together. And you can help me.
I think he has to do the solid modeling for the directions.
What do you mean?
When you do the solid model, which is done in 3D, he can actually say, looking at this, so he does not need to take photographs. He can create the solid model, and it's easier, and he'll break it into pieces. That's
So
what
he's
Nikki's
writing
job
the
is.
directions?
That's what Nikki's job is.
So he's writing the directions. Is he also incorporating the wire and everything with this one?
There's not much wiring.
much wiring.
I
to
know,
this.
that's why I'm
But
saying.
it's gonna be, yeah, it's gonna be easier, significantly easier.
You should ship one over to Nikki's dad. Have one of the kids put together and them take it.
We have 3 volunteers from Ashland University that are going to be coming to my offices early January. They're going to play with this one, and they're going to play with another one. And this other one is where I need to have ultra minimal pieces. I've got to literally do infrared, a remote control, or if it's in a D1, it's just your phone. There is no infrared, nothing else.
Do you have to program this?
Yeah. I'll put a basic program into it. Like this one right now has a test program.
So are you creating the program for them, or when they buy that, they have to program it themselves?
It will come with a standard basic program and some samples on the web, but they can program it themselves to do whatever they want. Okay.
Beep, 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 beep.
So it has some basic display stuff.
Wait, does that one have a display too?
Yeah.
Wait, do it. Put it on the thing so it'll go. Wait, why won't it just go?
Because the program right now is set up that if it gets bumped, that it backs away from the bump.
Just stay there.
Okay. The other program that I have, it actually moves slowly. When it hits something, it bumps back away from it. Okay. This was the early program. My bad. Okay.
So are you trying to create one where it's like the the little vacuum cleaners where they just
Very
go
simple.
and
Yeah.
bumps and it backs up and moves?
Yeah. Very simple. We're teaching people at a very lower, easier level how to build a robot, how to make it not bump into stuff. So if it goes straight to a wall, it can see, hey, I'm too close without even touching it. Then backs up, turns, and moves away.
Okay.
I'd love to have one that sees blocks and just navigates through the blocks, but that takes more than just one ultrasonic. What was the infrared array in front? Yeah. That's cool. I really was impressed with that one.
It's pretty neat. It works really well.
And it was
it works,
sensor bar.
It works pretty well. Yeah.
Okay. We started going through the robot inventory today. And I found a bunch of OLED that I had ordered as a sample.
Oh, cool. So you got more coming.
I've got 10 OLEDs, and I've got 2 that we ordered, one of this kind and one of the other kind.
If you're going to build a plate like this, I'd like to bust the I/O up to here.
No,
Ribbon
this is
tape.
just going to be a Arduino Uno and the motor shield on it. There's no other platform getting made. The motor shield has. Did you bring it? Mine's out in the truck.
Okay, so you're going to just have a motor shield on it, and you're just going to take your programming.
But on the motor shield, it has a spot for the servo, and it's got the buzzer, and it's got I2C breakout, and it's got all this stuff.
Okay.
So
Built in.
And if you plug your battery into the motor shield, it will power the Uno. Or you could tell it not to do that. So you could put up to, I think it said 24 volts onto that thing.
To power the Uno?
And it would power the Uno.
Sweet. Will it take power from the Uno side?
Don't know. That's why I wanted to play with.
Okay.
I haven't even had a chance to play with that yet.
My hope was that I could be able to just plug in
From the Uno.
from the battery to the Uno.
And get the power for everything, yeah.
That's
what I would hope too, but I don't know if it goes backwards or if it's just a one direction.
Because of the prototyping board and having the cable right over the prototyping board, I rotated the Uno so it actually gets the USB here and the power here. Okay, I didn't think it was really that big of a loss to do that.
Probably not that big a deal.
That white you'll sell low, that white, that's neat looking.
I have 3,000 pounds of this. I have 5 sheets of that.
Oh, okay. The white looks really good though.
It does. I know it does.
But
And it really doesn't get that dirty. I've been carrying this around back and forth for about 2 weeks. And in and out of my bag, on my desk, sitting it on top of my the dashboard of my car. Some of it was just a test to see, am I going to break it? But it's been doing pretty well. As much as I've been jostling it around. I feel like the wheels are getting a little bit rickety.
Mm-hmm. Yeah, they're bowing in like this.
Yeah, they're bowing in. This one, it still feel pretty good. But I have been using this one. I don't know if I actually tighten this one in very well. No, the wheels are just getting loose. But and we spent a lot of time trying to make sure that we got this overhang, dropping the motors as lower down as we could compared to the main chassis of the robot. Got these a bit close. On this robot, I actually cut off the one. They're going to be soldered on, so I don't think it really matters. We did our proper engineering to make sure that the screw heads were in the right place. The standoffs are down here, not interfering. So, I was kind of impressed with having lasered out the first one. The things kind of snapped in place.
It actually worked.
Right where we were planning.
Amazing what planning actually did.
Yeah, it was nice. The reason that I made the second one was because I had to turn around the board, and there was something else that I was like, this just doesn't seem right.
Well,
And I went ahead and moved it, and
it really does need to be flat. I mean, especially with the ultrasonic. So
fine. I made there's a lot of change to this. Just a little bit better fit. The bottom is a little bit different. Top's a little bit narrower. Some of that is because of how it fit into the layout. It's kind of funny how manufacturing plays such a big part of your design. But anyway, it went together nice. I'm happy.
Yeah.
So I would like to get some help working with a real level 1, level 0.
My opinion, just go back to the original design of the Biddy Bot, the original design where it's just
Too big.
Shrink it.
I think there's so many wires in that.
It's easy to build. There's 5 pieces.
I want to see if I can get the D1 Mini, as few pieces we can. Even this has a lot of pieces in the frame.
There's a lot of pieces in the frame,
Well, there's 1, 2, 3, 4,
but it's not hard to put together.
5,
6, 7.
6, 7, and then there's a spacer. 8. So that's 9, 10. Okay, I mean, if you're going to include that. So those are laser pieces. 11 if you want to include this. Okay. That's not the biggest problem. It's a little complicated to put together, a little bit. I wouldn't expect a 12-year-old to be doing it, but it's really not that bad. I don't think so. I want something with like 4 pieces. To go from 11 plates down to 4.
You've got
It's
the base plate, the ultrasonic plate, the top plate, and the 2 motor plates. That would be 5 pieces. Get rid of the antenna, get rid of the other
LC.
thing. Just go back to the very original design and you've got 5 pieces. You got the two motor. You've got the base plate.
And everything has to be accessible from the outside.
Well, that's where where you're gonna have to redesign the base plate or the motor plate. So
Everything has to be accessible from the outside.
I like that design. The original, before you got overly complicated with the extra top plate and all the other stuff, which I like. Don't get me wrong, I like it, but
At your level, yes.
but
At your work level, yes, it looks great. It
But-
works great.
the original design that was 5 pieces, maybe 6 pieces. I mean, it was elegant. It was simple. It was easy to build. And yes, the motors were on the inside, but you know, you could almost live with that. A level 1, maybe not, but
Well, I mean, can't you have them solder the wires on before they assemble motors into the chassis? Is that the problem?
We're just trying to make it.
you could.
No, I mean,
They're going to get so excited and they're going to try to put it together. And then be like, oh, I needed to solder this. I needed to do this before that. I want to be able to like, I've wanted to. I really have wanted to. I've really wanted to.
You could sell the motors already pre-wired.
Well, yeah, that's another option.
That takes up a
Don't want
lot of time. That takes
Because
Well,
that's
you
part
can get
of
it from China that
that's
way.
part
if
of
you're
their
buying
learning.
Enough.
part of
Okay.
the learning. It's actually in the
Okay.
the standards, science standards, that they should learn how to solder something.
Okay. Well, yeah, no, you can still have some soldering, but I don't know.
I got a little bit of soldering right there.
See,
On those two right there.
the original design of the Bitty Bot, you could go back, you could use the same shield that you want to use now. I mean, you could really simplify it, but that was just an elegant design. It was just simple. I'm sorry, it was. I love that original design. That was just.
This really isn't all that far from being the Bitty Rover.
It really isn't, but it's a little bit more complicated. I
The
think,
issue of the
I
AAA
think-
batteries is another thing I don't like about this.
I don't know for a fact, because I haven't really dealt with many newbies, but wouldn't a larger robot be easier to build for somebody who's uninitiated
Yeah,
in
but
the
it's
first
not-
place?
It's not easy to transport.
Yeah, but okay, the Bitty Bot's still not, it's not huge.
I mean, I would love to get, if I could find a different set of wheels, and granted, I just bought we went through the inventory a little bit. I got hundreds more wheels and gearboxes, okay?
Thousands.
Oh, gosh, it's killing me. If I could get smaller wheels, smaller motors, and the robot to be this tall completely. Those OLED displays, I kind of like that. Embedded right into the side.
Well, you can get smaller motors. Those
Yep.
N20 style motors. It's the generic name for them, but they're a lot more expensive, relatively speaking, than those are.
Yeah.
You're
That's part of it.
You're like me. I like the smaller robots too, but you know.
The part of having a smaller robot is that by comparison of the robot size, things appear to be going faster even though they're moving pretty slow. So having a slower motor, which is appropriate to the torque amount, which is appropriate to the amperage draw, your battery's gonna last longer, all that stuff. I've got a little robot that somebody gave me that the darn thing moves on the motor shafts. It's
Yeah,
the
that's
size of a
another
large
option.
cockroach.
Yep. Oh, I have some of those. I think the WowE.
And this is
Well,
one that
we
was made
came
by a makerspace in Louisiana.
Okay.
And
Well, we had
he-
some on-the-shelf robots that use that technique that are fairly good size. And
They
are
look
insect
like
shaped.
grasshoppers, didn't they?
Yeah, well, they had 4 different types.
Yeah.
There were
What
2
is it?
tracked ones and 2 direct-driven wheels.
Who is it that makes all those soldered together kits?
There's
That's you might mainly find them at the ham radio conventions.
what is that, Jamco or?
Not Jimco.
No.
Jimco sells them,
Yeah.
but they're
don't
they normally
remember.
come in like a little clear plastic box. They made a whole bunch of them. remember.
That style movement was popular with the beam robotics back in the day.
Yeah.
I don't know if anybody still does beam or not.
I Googled them not too long ago, and there's still a few, but it's not a.
If it's a light robot, you can get away with that. And
Yeah, it has to be tabletop surface, glass surface.
yeah, it has to be
You're
flat
not going to have
surface.
any carpet.
No.
No way. I want something that the wheels are the size of a nickel or a quarter. With the rubber edges, tiny gearbox. I'd love to find something that small. Even like a
Well, again,
continuous rotation 9G.
with
that'd
the
be a nice
stipulation
fit.
that it's cheap, right?
That simulation
You
that
can
is cheap.
find them all you want, but they're not cheap.
Really freaking
Page-
cheap.
Pager motors, old pager vibrating
Motors.
Yeah,
Those are
those
cheap.
are cheap,
Those are
but they don't have a gearbox.
no, but they're cheap.
And at the right wheel size, they don't have to have a gearbox.
Right. Well, again, it's if it's a light robot, very light, then yeah, you can get away without it.
Off topic. Next topic. Or is it just a side note? One of my customers in Carlisle is a new customer like 3 weeks ago. He is a managing partner of an injection molding facility.
Ooh,
Okay.
we
So-
need to be friends with him.
They do tens of millions of dollars of work per year. Like 200 or so million work a year.
Wow.
Multiple buildings. And I was like, well, can you help me with, if I buy a small injection mold machine? He's like, don't waste your time. Don't waste your money. But so all they do is, injection molding.
Right.
You know how big a die is for injection mold? I mean, the smallest one I've seen, you can make it out of 3D printing.
Oh, well,
You
sure.
can actually make it a die.
If it's low,
Okay.
pretty low pressure, yeah.
Yeah, you're talking a 3-ton, 5-ton press. Okay. The dies that he has, this wide, that deep,
Yeah.
that tall. They use a crane for loading them. 160-ton, 200-ton presses. Amazing. They're doing them for they're injection molding parts of the dashboard for automotive industry and
Sure.
for it's amazing stuff. So he says, don't waste your time on injection molding. Buying a machine. Just make your dies. I'll help you design them and bring them in. We'll just knock out a few thousand parts in a weekend, and you just pay for the resin, the raw material. I was like, sweet. This is gonna be awesome. I'm making Omni wheels. No more bearings. Making Omni wheels. So we'll be able to make drive wheels and Omni wheels.
That is sweet.
That will be so nice.
That's
like years in making though for me.
There is a company in Hamilton that sells Omni wheels. They make them up there, and they're conveyor belt wheels is what they are, but they can be used for
Yeah, you're probably talking expensive on there though.
$4.
Yeah, they're relative. Yeah. Which company is it?
It's starts with a K.
Yeah.
K-Mac.
It's almost a Japanese sounding name.
Cayman?
It's almost Japanese sounding, but I think they're Swiss.
Yeah.
I think it's a Swiss company.
Okay.
Yeah, they're relatively cheap.
Yeah, they're conveyor belt wheels. They're not they don't have 2-side Omni wheels. They've got just the one
row.
and they're tracked so something can
Well,
push
the
them
ones I'm
off.
thinking of is like 3 or 4, 5 wheels.
Yeah.
But they're offset from
Well,
the
those-
left side, right side.
Yeah, those are expensive. These
Okay.
these are cheap. These are like $4, $4 or $5.
So one of them, you could also stack them together in
Yeah.
such a way that you get offset rollers.
But you could probably do that with a bunch of different things. But the guy in Hamilton, he said they don't really have a showroom or anything, but I talked to him once and he said, just get some people together. I'll show you. I'll come up and we'll
Yeah,
give you a
fun.
tour. Okay,
I
cool.
would like to do that.
Sure, yeah.
I've got 8 days available.
Wow, okay.
I'm not going out of town for the next several days.
But-
I've been told that. We hope that stays true.
But yeah, I wanted to get some of those Omni wheels just to play with, just because they were cheap.
You were at the office today?
Hmm?
Did you notice those people?
Next door, the car broke down or something, maybe?
I don't know what they were doing. They had electronic equipment and chairs. They were sitting out there.
Really?
I don't know what they were doing. At one point, they were by your, that first building.
It's not mine.
And then, oh, the very first one's not yours?
The building towards the front, it's actually 1300.
Uh-huh.
And then next to that is 1310.
Okay,
And closer to the Rabbit building is 1316.
right.
Okay, so 1300, 1316, 1300, 1310, 1316, and then 1320. That one up in the corner, which is like right next to, or right across the driveway from all the storage.
Right.
That's not my building.
Okay.
That
They were
building
part-
has EDA issues.
Yeah, oh, I wonder if that's what they were doing. Because they had electronic equipment and they were parked there for a while.
Ghost
Then
town.
they moved down onto the street in front of the rest of the storage. So I was just curious. You were curious because I was up there today working on the robot
So
stuff.
that wasn't with John's?
No, I don't know who those people were.
Okay. John's working on robot stuff too, again?
Bigger stuff. We're working on right now wheelchair-based size robots. So
Okay. Is that police surveillance stuff?
no, actually, it's a goofy. This one's a salt spreading.
Salt spreading robot.
It's just an excuse for it to do something while we're getting all the software and electronics hooked up.
Cool.
He had it last year as an RC controlled, but trying to make it more autonomous this year.
Salt spreading. Okay, whatever.
Anybody want to see my thing?
Yeah, of course. I'm not here just to do me.
Anybody want to see what I got?
No,
Go for it. I didn't think so.
in the 5 minutes we have left,
I'm so sorry.
or whatever.
Out of time.
Out of time. Done. Okay.
What are you doing? I missed the first part last week.
First part didn't work, so you
Oh.
didn't miss much.
Gotcha.
Programming the Raspberry Pi with either Arduino IDE,
Ah,
Particle Cloud IDE, or
Here,
just in pure C.
I'll get that out of the way.
So
I'll let you just take it. Because you're going to review stuff on it anyway.
I am going to. That's the one-
original.
That's
The
version
unflat.
2.
Yeah, I get version 2.
Basically, this website, not this website, that's not a website. This website right here. Oh, jeez, we're back to that, are we? Not wanting to do stuff. There's a website on GitHub. He's got a board manager set up for Raspberry Pi. Once you set it up, you install some software on the Raspberry Pi as well, which is a little complicated to do. There's like 6 or 7 steps.
Yeah.
I finally figured out that you really only need to do like 4 of the 7 steps, but he provides a board manager. You just install it like you normally would with an Arduino board.
Mhm.
It shows up once the Raspberry Pi is powered up and you've got the right software installed. It just shows up on the network as a network board. And you pretty much use it like you would with any other Arduino,
That's cool.
except I have found that some of the libraries don't work and some
Well,
other stuff.
Yeah, sure.
There's some other
It worked great with a Pi Zero W. It'd be cheaper than an Arduino.
It was designed,
Or unofficial Arduino.
it was designed for the Raspberry Pi 2.
Ah, okay.
It works best with the Raspberry Pi 3.
Well, sure.
The Raspberry Pi Zero, I had some issues with some of the pin numbers and whatever not working correctly, but I'm sure all that will be resolved sooner or later.
Yeah.
So this is the 3 that I've got going on. And you use the GPIO numbers for your pin number, which is a big thing to know because otherwise you'll be completely lost. It
They don't
shows,
have, yeah, I guess it'd be difficult to have any kind of mapping to Arduino type pins.
it shows right up as right there.
Because the Pi by itself doesn't have any analog input pins, does it?
No,
Yeah.
and you can't use any analog input pins either.
Yeah.
So you can see it's not really doing anything right now. I've got a PWM sketch. It's only got 4 PWM pins too. It should, oh, it's asking for the password. One thing I don't particularly like about it is you actually have to set it up for a root user with no password.
Oh, boy.
Guess if it's on your own network, it's
Yeah,
not that big a deal.
Yeah, probably not, no.
So it was just that simple. Blah, blah, blah. And
I could see some people might find that interesting.
well, I said,
I've never bothered to use the I/O pins on Raspberry Pis. If I want to do any I/O, I slap an Arduino on there and have it do all the low-level stuff.
I haven't really until, because I always found that programming it was just kind of a pain. But now I'm starting to get into maybe it might be useful. There are some things. So
See the red light on there is kind of glowing right and down, right.
that's PWM doing that.
Mm-hmm. PWM means pulse width modulation.
Pulse width modulation.
It's a way to turn it on and off really fast, but the percentage of on and percentage of off.
Gotcha.
The other thing it does, it sets up a telnet.
So you can get a serial console.
So you get a serial console.
Well, that's cool.
So I can actually see what's going on here. Eventually, when it decides to actually connect.
Are you using a serial monitor from the Arduino IC?
Yeah. Yeah.
Okay.
Oh, it's 307 degrees. That can't possibly be right.
Oh,
I thought
wow.
it was a bit warm in here.
75. I don't really think that it's telling me good temperatures, but it's sort of working.
100 degrees at 77. That's good.
So
Close.
yeah, it's got to be somewhere in there.
77.
So as you can see, it's just as easy to program. Now I could SSH into it, and I've got here. Now the really cool thing is once the sketch is compiled, it's actually an executable file. So you can actually
Run it by hand.
it's local. Local LinkedIn. So where it says Arduino sketch in red, the very first thing. And that's the same sketch that I just. And now I'm running that directly on the Pi. So you can copy that and save it for whatever. And so since the Arduino sketches have to be run as root, you have to do it with sudo.
Sure.
So that's the same sketch, but I had already saved it as something else. And so that opens up some possibilities to actually write some programs to actually do something.
Mhm.
So that's just a simple blink on, blink off kind of thing. The other thing, Particle Cloud, that is not the right one. Particle Cloud opened up their IDE to experiment with doing the same thing with Raspberry Pis. Its setup is very, very simple. You run one command. Eventually, it gets to a point where it asks you for your particle username and your particle password, and then it asks you for a device name, whatever you want to call it. It works very, very similar to how the Arduino works. In fact, Particle was based off of Arduino. It's not exactly Arduino, but it's close. With a couple of exceptions, there's no serial console, so I can't like easily look at an output from there. There's ways to do that, but it's a little bit more complicated. But one of the benefits of using Particle is I can write some web apps. So if I hope it works, so this is a web app that will flash the lights once I go to the website and tell it to turn the lights on and off. So it says flash successful. You see nothing's happened. I go over to my web app, which is very, very simple. Turn the LEDs on, and all of a sudden they're on. Turn the LEDs off, and they're off. So that's a benefit. That's one of the benefits for using Particle Cloud. The other is they make managing your devices a little bit easier if you out over great distances. I couldn't get the DHT11 to work with Particle at all, though. So there's definitely some weird nuances going on that I just was like, okay, I got it working with Arduino. I got it working in Pure C. That's enough. I'm done. Not spinning all day long. So the last thing that I've got, this is SSH client into the Pi. So the last thing would be doing this in just a Pure C environment. And these are basically just text files. So this is the program for running the temperature sensor. And you can see it's similar but different. It's using wiring, which is what Arduino was based off of, but it's more of a C structure because there's a main and not a loop and not a setup. It takes a little bit of getting used to, especially coming from Arduino to Pure C, but it's close, and it's close enough that it's not that big a deal. And you compile your sketches with GCC, and the only thing you've got to add is you've got to tell it where the library is, or to use the library. So we want to compile this as, and it's going to be DH. Takes it a couple seconds. And one of the interesting things about this is I don't think I have to use it as a root user.
Yeah, well, yeah. I'm assuming that.
If I use the pulse width modulation, I have to use it as a root user, which is, I don't know.
To get access to the various peripherals.
Some of the peripherals, yeah.
Yeah, I've never looked at how they've set that up, but I can imagine that you have to have a particular user or have your user in a particular group get access to the stuff.
Yeah.
That's why you're having to run this route for some things.
If I try to fade, I definitely, if I don't run it as a root, it actually unmounts the SD card. Yeah.
Oops,
So
that's bad.
the fading program is basically the same. It's almost identical to the fade program for the Arduino. I mean, other than the fact that there's no loop and no main, it's actually wiring uses its own set of pins numbers, so
Yeah.
which is a pain because you're looking at one thing and you're going, why is this GPO 18 and why is it pin 1? Why? It's not even close to pin 1. But whatever, you know. But so there's that.
I was just looking to see if Platform IO supports the Raspberry, but it doesn't look like it does.
There are a couple of other online IDEs that I found that do, but Particle is one of the easier ones.
Oh, there's something called Wiring Pi.
Wiring Pi, that's what I'm using.
Okay. Apparently you can use that through Platform IO.
Um,
IO is just a command line version of, well, they have an ID, but it's also, the core of it is a command line interface. I've been using it on our robot, so, because I've got a headless computer on the robot, and if I want to reprogram the Arduino, I don't want to have to disconnect it,
right.
plug it into a laptop. With Platform IO, I can do it all remotely.
It's kind of like Particle. I mean,
Yeah.
Particle, because it's cloud-based, it's out there somewhere, and it's
Yeah.
connecting to you remotely. So my Raspberry Pi could have been sitting at home, and I could reprogram it. It's really, really simple to set up. Now, the one thing that I've noticed, especially when I'm on the command line, is if I stop the program with a Control C or whatever, notice how the lights don't go out or whatever. So I found that
Yeah, I'm sure it leaves them in whatever state they were on
it does.
previously.
I have found, though, that if I just run a blank sketch, it clears all that and it resets everything back to nothing. And I have to, because of the way I've done the new demo, last week's demo, I had three separate partitions. I was doing all three of them in separate partitions. But because of my new demo and it all being on one partition where I don't have to switch things around, I have found that if I'm fading with like the Arduino and I try to do something with Particle, both of them are fighting for control, and it's really neat because you get flash, fade, flash, fade. But I found that if I clear it first with an empty program, it fixes that problem. So that's pretty much my demo. It's been fun, and I like now that I can actually use this thing remotely. Well, I don't so much mind it being physically connected to something, but I like how easy it is now to use the I/O. I mean, it's right there.
Yeah.
I don't need to really do anything extra. I'm used to how the Arduino IDE works.
Mm-hmm.
I'm used to how Particle works. And if I really want to get into it, I can mess with the C code. I like that the Arduino is compiled. I like that the C is actually compiled code. I can run that. I could copy that code and run it on any Raspberry Pi, well, any Raspberry Pi 3, since that's what I compiled on. I cannot find, I am sure that the particle code is compiled somewhere. I can't find it. I have no idea where it's actually, where they actually store that code at. They call it firmware.bin, but I can't find it. I have no idea where it's at. So you can see there's actually firmware.bin is running, and the Arduino sketch cleared it out. So, because the Arduino sketch was empty. Also, if I try to kill firmware.bin, it comes back. If I kill the Arduino sketch, it won't come back. It's happy and goes away. So, for that reason, I like the Arduino a little bit better, but for the fact that the Raspberry Pi could literally be anywhere and I could program it with the particle. I like that. I like it. So that was my demo that I tried to do last week. All of 5 minutes.
On the Shark Tank last week, I saw, it's probably from a while back, they had a Barbie robot. Are you ready for Barbie?
Yeah.
Did you see that?
I liked it. I thought it was neat. It walked. It drove around on a Segway.
Yeah, it was basically
That was
like a
kind of
Segway.
interesting.
So balancing robot.
Yeah.
Yeah.
I saw
Kinda
that when that lady kept saying that the algorithm was complicated and hard to do.
What it had was the little controller. It had steps forward, steps back, turn right, turn left, all that stuff. And then
For little girls to program it.
For little girls to program it. They said,
Yeah.
yeah, this is lame. Well, what about the code? And he flipped the switch and it showed the code. And you could change the code. You could write the code. So the C code. So, okay.
That was it was Scratch was basically